The shop lab is designed to be a mini factory to continuously exercise the shop system, printing hundreds of parts a day for ourselves and for our customers. So the shop system is the first metal 3D printer designed specifically for machine shops, allowing shops to enter into additive metal manufacturing like never before. The shop system is a single-pass, high-resolution metal binder jetting system at a price point that has never been achieved before. The shop system is an extremely easy system for machine shops to learn to use. Powder is loaded into the printer, and the printer autonomously lays down 50 to 100 micron layers of metal powder and prints batches of parts. The customer can load as many different parts as they would like into that batch, and it does not change the time. The printer then ejects that batch of parts, which can move on to the next station, and the printer can begin another batch of parts. The next step in the shop system is the depowder station. Now, the shop system is a batch process, which means a batch of parts can be printed, and then that batch can be moved on to the depowder station, so another batch can then be printed at the same time. The depowder station is a fully integrated depowdering station where parts can be excavated from the powder, and that powder can be fully recovered in the integrated recovery system. Those parts, once excavated, can be placed directly into the desktop metal furnace for full sintering. Sintering technology has evolved over the years to be huge furnaces that cost hundreds of thousands of dollars and take up entire rooms like this. But what we've been able to do here at Desktop Metal is shrink down that same technology into a small furnace that is vacuum capable, partial pressure capable, and can roll through a door. The shop system is designed to scale manufacturing from small scale to medium scale to enhance a machine shop, whether it's an external machine shop or an internal machine shop, with 3D printing capability.
Now we think in triangles and squares and circles, and our math tells us that that's the way things work. If there's anything that's coming down the road that could potentially obsolete some of the ways that we currently manufacture, we want to become the best at that new technology.
UMC is known for our precision machining capabilities. We work with the top 10 medical device OEMs and high-level aviation and aerospace customers. And that has us dealing with regulated environments that continue to stretch our internal capabilities.
We are about 70% medical. The other 30% of the work that we do is aerospace.
Our machines are known for their ability to hold tolerances that need to be exact. They have no room for error.
We go down to the submicron level, down to 40 millionths of an inch. To put that in perspective, a piece of human hair is about 4 thousandths of an inch thick. So we're 2 decimal places past a human hair.
So it's been very important for us to be in this conversation and partnering early. For us, offering the metal printing as an option to understand the interaction between traditional methods of machining and these additive methods maintains that competitive edge for UMC.
Desktop Metal has been a great partner. We recently installed our studio system, and so we started using that for fixture molding.
We're using the additive manufacturing quite a bit for end arm effectors, so we can use the organic capabilities of the 3D printer to form to those parts better and manipulate them better. We're also using them to integrate some of our safety sensors and anything that's custom. We can print a 3D printed bracket to fit right into the cell how we need it to. Being able to use the printer, we can print fixtures that more closely replicate the parts that match the human body. In the 3D printing world, having that less is more mentality, shorter prints, less used, less cost associated to us.
It's touched a lot of different areas of our plant. We have utilized it now to the point where we aren't really able to go away from it anymore. We are dependent upon it, along with our conventional machining, our tool room machining. Additive has just helped us do those little extra things that would have been much harder to do had we not implemented it.
Not being a part of this conversation will be a completely missed opportunity.
If we don't start down the journey right now, we'll never be ahead of it.
I'm very excited about it. I think it's a great technology and it can only get better with time. And as we learn more about it, it becomes more integrated into what we do and we'll be able to better utilize it than we even currently do.
Seeing 3D printing coming on the scene, partnering with traditional manufacturing, it's going to be a very exciting time to see where this goes. When the Wright brothers took flight, that changed the world. When the internet came out, that changed the world. Every single industrial revolution or every single change that we've had in manufacturing, the next one happens faster than the previous one. Our world's going to change fast as far as just technology, the way that we look at doing things, and really metal printing fits right into that. And so this is definitely going to catapult us into a new era.
These parts with traditional manufacturing methods, the cost would have been somewhere around $10,000 and probably 4 to 5 week lead time. We were able to make these parts for about $150 and it took us about a week to get them printed, debound, and centered.
This region's right next to the Allegheny National Forest and the Appalachian Mountains of Pennsylvania. And really what the core manufacturing of this area is the powder metallurgy industry that was bred out of the carbon industry. A lot of small towns inside the Tri-County area, a lot of blue-collar workers that really have a trade that they should be proud of. It's an integral part of the automotive industry and manufacturing in general, all the way from steel production, aerospace, defense industry, medical industries, all leveraged as part of the manufacturing in this area.
Right now we're in A.E.B.E.'s Sintered Metals Division. We're back in their secondary operation where we're doing CNC machining. This would be the old machine chuck jaw. It has less geometry capability in it, and also it takes a long time to machine from the shop as we're doing this out of tool steels. We've printed a set of chuck jaws for a complex geometry, and it perfectly matches the profile of part that we need to machine an ID on. We printed them on the studio system, and right now we're going through tests to compare them versus the traditionally machined components. The benefits of printing is we're able to make a more complex part geometry and also iterate the design more quickly.
Innovation is not a new thing here at A.E.B.E. We've been a leader in high temperature sintering for decades.
We service a lot of different industries, mainly automotive. We also work in the small engine, lawn and garden, firearms, the defense, medical, aerospace, and consumer markets. We are a global provider of metal formed products. We ship conventional powder metal parts all over the world. We ship MIM parts all over the world, and we're getting inquiries from all over the world for 3D metal products. We have that scale and that capability to service the entire world with our technologies.
One of the problems was a lack of labor that we had to give to our CNC department. So one solution to that problem was coming up with a way of using the machine to tighten and loosen the Allen bolts as well as pick the parts in and out of fixtures. This was all 3D printed on the studio system. You can see the complex geometry, the coring for lightweight, the radiuses, all stuff that'd be very difficult in traditional manufacturing methods and very, very costly.
We started looking at all 3D printing technologies. The thing that brought A.E.B.E. to Desktop Metal is the level of investment required for us to explore the technology was much different scale than if we were to go out and buy a DMLS machine.
What we're doing with the studio system is we're manufacturing the end of arm tooling for the camshaft assembly. Also, as we're doing design changes to a camshaft, there's some complexity changes that we need to do. The studio system has allowed us to make some of these complexity changes and also inventory the end of arm tooling on the shelf so the line's not down at any time. This is the end of arm tooling. What we've been able to do is lightweight this by about 30%, so it's easier on the 6-axis robot, and we're also able to add in some geometries that we wouldn't traditionally be able to do with machining. Currently, this is on test, and what we're able to do is test the hardness, test the cycle times, and see how it compares to a machine version of the assembly. Once we're finished with testing, we plan to move this to our production floor to add flexibility to our work center.
Early on, we became partner with Desktop Metal in the studio system. The team here developed a very innovative bridge to production system, which greatly shortened the time from product award to product launch.
90% of our additive use right now is for internal capabilities, helping us get our customers to market faster, helping us keep inventory items on the shelf that are wear items throughout our facility. We're not waiting for the tool shop or an outside supplier to build fixtures, jigs, end of arm tooling. We can design it in a day, we can print it in a day, and then it's ready to be deployed to the floor in less than a week. powder metal industry has been stagnant for some time. There's been some advances, but adding this technology gives us a leg up on our competition, allows us to put another tool in our toolbox.
With 3D printing, one of the cool things is it changes how you think about things. And once you have this flexibility to design any way you want, there's no going back.
Bringing on the studio system from Desktop Metal has allowed our internal engineers to think differently in how they're designing products, how they're designing process flows.
It does help secure the future of APG because this is a manufacturing technology that's extremely flexible. It can be applied across a wide range of technologies, a wide range of customers. The applications are endless and being developed daily. We don't see this technology as a threat. We see this technology as a promising new opportunity.
We're extremely excited to get the production system in-house at Alpha Precision Group. We have a space available. We're excited about building it out and making it ready for the future of manufacturing with the production system.
We're now able to attract different forms of talent to the area that we wouldn't maybe traditionally have. Additive manufacturing and technology, it's a fast-paced environment. So people like myself moving back into this area that might not be attracted to the more traditional manufacturing methods, this is something exciting that we can propel into the future and really leverage a lot of the expertise that we have in this area, and then also bring in new exciting ideas.
Johns Inc. Company designs and manufactures emissions control equipment and clean air combustion equipment. Our primary goal is eliminating waste from the environment so that our customers can operate safe, efficiently, producing the products that they do. My name is Jason Harjo. I'm the design manager for Johns Inc. Company in the Flare product group.
So my name is Bert Reelhouse. I'm a manufacturing engineer at Johns Inc.
I'm Paul Newman. I'm the general manager for Johns Inc. Hamwilly over in the Poole office in the UK.
We're always looking for better ways to serve our customers, to help them serve their customers.
In order to get where we wanted to go, we need to do something different. We need to reduce the amount of restrictions we had on how we manufacture things.
When you look at our manufacturing environment, it's more of an engineer-to-order environment in that we're not making a bunch of widgets, thousands of widgets per day. It's more one or two or maybe dozens of burners at a time.
We're out looking into every opportunity that we can to utilize additive to solve a problem. You can only do so much with traditional manufacturing. And additive opens up a whole new door for new designs where you have internal pathways to certain parts, where you can get more efficient mixing of maybe fuel and steam as in an atomizer. But that's really the problem we're trying to solve is newer designs, more efficient designs to operate our equipment more efficiently. This is a YE6 burner tip. This was installed in a thermal oxidizer burner. And in a thermal oxidizer, it's burning and creating temperature to effectively destroy waste at the end of a process. This is very critical to the function of a system because this is what's going to shape your flame to burn efficiently. This part hadn't been manufactured in about 30 years, and so the tooling was gone. And so we decided, hey, we're gonna print this part, and now we have a successful part, and we didn't have to buy tooling for it. So normally with a part like this, you're investing thousands of dollars worth in tooling, and that's just to get started. And then you have to manufacture the parts. And then there's the lead time to not only manufacture them, but ship them to you. But with the studio system, we're able to print it and debind and center it in a matter of weeks, as opposed to months. And it also could run us several $100s as opposed to several $1,000s.
For me specifically, the most important part of having a studio system in our shop is being able to design a tool or fixture and have it produced quickly. One example that I have here is a design from a machinist that's been with us for about 30 years. And he has these really heavy tools that he loads into his lathe. And the way he's been grabbing these parts over the years just with his thumb and his index finger. And that's a lot of weight to load in on one part. Now on all of his tools out there at the lathe, he's got about 30 of these tools with the handles on them. They're all drilled and tapped, and he now uses the handle here to load his parts in and out of the machine. What we did is we first printed out a plastic. We tried the handles, he loved them, but over the course of a week, he says, hey, my plastic part is broken. I said, okay, well, we've had this metal printer, so we can print it out of metal for you, and that thing's not going to give you any issues. It made sense to print this part versus machining it, because we would have had to take a pretty large chunk of metal and machine this down, especially to get this curvature. So it would have been time consuming and taking up our resources, where we like to focus our resources on making products for our customers. So one of the examples of parts that we're able to implant in our shop is this nozzle. It's used on our laser. Essentially, we were cutting some tube that created a lot of slag and buildup on the inside. So this is a really complex geometry. It's got multiple channels in it. So you have one port that directs the flow, concentrates the flow of gas, and then you have another port that kind of creates a plume. You cannot make this any other way. It can only be 3D printed. The first thing we did was 3D print it from PLA. So we printed it on one of our desktop printers. We threaded it, put it on the end of that gas nozzle, and we tested it out. What we found that it was very effective, but it didn't last very long because the heat caused those ports to melt shut. Basically just disintegrated the tip. Then we went to the metal part, which we knew was going to be our long-term solution. So now this part can be threaded onto the end of that gas nozzle, so it purges the cut as it's being produced, creating a clean part that doesn't have any post-processing.
We were always pushed and pushed and pushed to try and reduce the amount of fuel we were burning. So we were looking at how we could improve this. And one of the things that we found out was if we could improve the mixing of fuel and air, we can reduce the amount of fuel we burnt. If we could create some other form of mixing using the atomizer, for example, that would create a lower flow of fuel oil, which is what we were targeting. This is a conventional atomizer. The concept is that you've got steam going into the middle and oil around the outside, and there's a mixing port that you end up with an atomized fuel. This is made out of a conventional piece of bar stock. The outside is machined to just give us the shape that we need, and the holes are drilled with conventional drilling machines. But you're pretty restricted on what you can do with it. When we knew that we could use additive manufacturing to create metal parts, we were still under the mindset that a round hole is the only hole you can have, because it's just ingrained in us from a design point of view. So the first thing we looked at was how we could get air into the middle. So we thought, let's remove this material around the outside of the hole and just have tubes coming from the center. We ended up with something along the lines of this. This is obviously made out of plastic and a slightly larger scale, just so that we could look at it. But it's got the ability for air to get into the center, which is what the target was at that point. And we slowly understood that with additive manufacturing, we're no longer restricted to round holes. We want to improve the atomization, so let's not make a round hole, because that's not necessarily the best way of doing it. Because when we came up with this, which is our final design, and we've done some CFD flow patterns across the face of this to have a look at the airflow, and it is vastly improved. So using the conventional atomizer, we could reduce the flow rate of this down to about 120 kilograms an hour. With this one, we can get down to 38 kilograms an hour. And if you imagine that's firing 3 burners, that's 3 times that over the number of ships they have, firing however long, it's a huge saving in fuel oil. When you're looking at the use of additive manufacturing in the process that we were looking to achieve here, the prototyping gave us the chance of testing things very, very quickly, so that was an advantage. But the biggest advantage was simply the fact that we were no longer restricted to this simple round holes at certain angles. This, you can do anything.
Desktop Metal has a system that has a very low-cost entry point into the technology.
I think one of the biggest benefits for us in working with the studio system is that it did not require a lot of PPE, because of the fact you're not dealing with any free, powder metals. That it makes the process really safe and easy to work with.
Preparing the facility there's no real cost there. Basically, you plug it in and you can go.
In terms of industry applications, applications. It's very, very versatile. You can use it for all sorts of things. There'll be a lot of gains you can get from a design perspective.
Companies that feel like metal 3D printing is too far in the future, if additive manufacturing adds value to them whatsoever, and they're not investing in it, then they're already behind.
The limits of additive manufacturing are only what you can think of creatively, right? So anything that you can think of, you can pretty much print.
Without additive manufacturing, there's no way we'd be where we are now.
Innovation is in our DNA at Ford. We've been innovating ever since the moving assembly line. We've carried that tradition forward with the work we do here in the Research and Advanced Engineering organization. This organization is responsible for developing new technologies and working with partners to bring those technologies to Ford Motor Company. We're using 3D printers and prototyping of parts right now. It's uniquely suited for that because we can print parts right after you design a concept and see if it's the design that you really want. And that opens up a new design process where you can iterate more quickly. Ford is a pioneer partner of Desktop Metal, and that's given us access to their equipment. We've had a Desktop Metal studio printer here, and we've been using it to print parts, to evaluate the materials, then to evaluate the parts that are printed on it. Building on that innovation, we now have advanced 3D printing methods like binder jet technology, which opens up the possibility to 3D print at much higher speeds and at much larger scale. These 3D printed parts can be used to prototype components that go into our vehicle. We also use them to make manufacturing aids and fixtures, and we're increasingly using them now in limited scale production examples as well. We have in production a GT500 part. That's one of our performance vehicles. We're really excited about bringing that to the market later this year. And then on our F-150 Raptor vehicle, we have a 3D printed part that goes into one of the electrical plugs that needed to be sealed off for a particular market. So it's a great example of where a 3D printed part could go into a region and modify the vehicle to be sold in that region without disrupting the at-scale manufacturing process for other regions. But long term, as you look into the future, we're looking at many ways to integrate 3D printing into what we call the factory of the future. We're prototyping many concepts today, both in virtual space and in the physical space, where we're proving out some of those concepts. We see the possibility of creating future factories where 3D printing is an integral part of the manufacturing method that's used in that future vision. That's why we're so excited to be partnering with Desktop Metal, because it's opening up the possibility for that scale to be realized at Ford.
Right now, we think in triangles and squares and circles, and our math tells us that that's the way things work. If there's anything that's coming down the road that could potentially obsolete some of the ways that we currently manufacture, we want to become the best at that new technology.
We're out looking into every opportunity that we can to utilize additive to solve a problem.
Adding this technology gives us a leg up on our competition, allows us to put another tool in our toolbox.
Our customers are under continuous pressure to innovate. We're now able to make products that otherwise we would have never been able to make using any other type of technology.
We're always looking for better ways to serve our customers, to help them serve their customers.
What I'm seeing in my teams is this new thought process that they've developed. They are challenging the way that they would traditionally design a method for manufacturing.
And once you have this flexibility to design any way you want, there's no going back.
With A.E.B.E technology, which are developed by Desktop Metal, we're able to increase production rates, decrease the global cost, but in the same time, we're able to increase the definition and accuracy of the parts.
So Ford is a pioneer partner of Desktop Metal, and we're looking at many ways to integrate 3D printing into what we call the factory of the future. I think customers are going to love the way that 3D printing can customize parts just for them. You could imagine tailor fitting or printing the seat to your particular body shape. There are many possibilities here, and we're looking forward to the next iteration of their technology, which is the production system.
We're extremely excited to get the production system in-house at Alpha Precision Group. We have a space available. We're excited about building it out and making it ready for the future of manufacturing with the production system.
MIM currently is the largest player in the metal injection molding area. The MIM tooling can be anywhere between $20,000 to $100,000. A lot of times the customers, either change their design and move away from the metal injection molding. So we want to be able to be the first in the industry who can provide samples for the customer evaluation within days, not within weeks or within months, and that too at a very, very low cost. Probably fraction of the cost that currently they are spending. And Biojet 3D printing is definitely capable of achieving that. That's why we fell in love with Desktop Metal from day one, because they talk our language, the production systems.
Companies that feel like metal 3D printing is too far in the future, if additive manufacturing adds value to them whatsoever, and they're not investing in it, then they're already behind.
It's touched a lot of different areas of our plant. We have utilized it now to the point where we aren't really able to go away from it anymore. We are dependent upon it.
Not being a part of this conversation would be a completely missed opportunity.
And so that's why we're actively working with companies like Desktop Metal so that we can drive that future as opposed to letting it happen to us.
What is happening here is extremely important, not only for the future of manufacturing, the future of industry, and the future of business, but for the future of our civilization itself.
Και αφού είδαμε το μέταλλο και την τρισδέσατη εκτύπωση στο μέταλλο, θα προχωρήσουμε στην τρισδέσατη εκτύπωση σε πλαστικό. Επίσης, να σημειώσω κάτι, ότι όλες οι τεχνολογίες που είδατε στα βίντεο υπάρχουν στο εργαστήριό μας. Για περισσότερες πληροφορίες είμαστε εδώ για να σας παρέχουμε ό,τι πληροφορία θέλετε. Θα συνεχίσουμε τώρα με το πλαστικό.
My name is Al Sabani. I'm the CEO and founder of Envision Tech, a global 3D printing company. What I really enjoy more than anything else is the idea of wanting to make something, wanting to innovate, and really being able to put a lot of hard work into it and try as much as possible, never give up till you deliver something of value. And that's what I did. I was in the 3D printing space for quite some time, and I had gotten a chance to evaluate all the different technologies out there, and I was looking for a technology that would fill the gap, deliver 3D printed parts that others could not deliver. I felt that there was definitely a need for a printer that can deliver very highly accurate part with very, very high resolution. And so I started looking at what markets can benefit from that type of technology. And the first one that came to mind was the jewelry market. I was thinking that in the jewelry market, with the product that I have built out of my living room, I'll be in a position to go out and actually sell the product. So in March of 2003, I took my first printer to the first trade show and started building parts right at the show for the first time in jewelry. Historically speaking, there was not too many people that were doing that in the jewelry market, and it would take days to print one single ring. Here I come in and I can print in hours a ring that has very high resolution, that has very high detail, and that was the beginning of the commercialization of DLP 3D printing. In the medical space, we were able to allow the dental lab business to flourish, especially in the United States. By using our technology, we eliminated the labor cost factor that a lot of the countries outside the United States were competing against us. That's one thing. The second thing that I'm really excited about that I think will have a significant impact on the quality of life for people is the bioplotter, the biofabrication, and very specifically regenerative medicine. Those type of customized implants or customized medical parts are going to allow for a better quality of life for people, and I'm really proud of it. Prototyping using 3D printing as opposed to the standard manufacturing techniques became viable over the years. However, as the technology evolved, as the speed evolved, as the accuracy evolved, coupled with the most important thing, which is material and material functionality, we are entering the new phase of 3D printing of real manufacturing. So for me, I think that a company can only continue to grow and succeed as long as you continue to innovate. And that's really what I think about every morning is, what is the areas that I think we can deliver products that will disrupt markets and make a difference in the manufacturing base, whether here or globally. And with that in mind, I'm always very excited about working to deliver a solution that traditionally has been a problem for the manufacturer, or is too cumbersome and it's too costly. So if you look at the history of EnvisionTech, we are innovators, we are not copiers. We were the originators of the DLP technology. We were the originators of the bioplotter. We were the originators of the robotic additive manufacturing process through the acquisition of Firidis 3D. And if you look at the 3SP technology, we were the innovators of that. What really makes us different from everybody else is that we invent, we innovate, and we captivate the market. We never reinvent anything.
When I think about the company EnvisionTech and how it's changed 3D printing, it's an incredible change.
3D printers from EnvisionTech are the magic wand that allow you to provide the really accurate, aesthetic, and timely result. The potential of EnvisionTech technology is pretty profound.
If you can think limitlessly, this technology gives you the technique to actually be that designing giant that you wouldn't be able to speculate about or to dream of.
All of our additive technology and systems are mature technologies, they're well documented, and they're stable platforms, and they're very cost effective.
Our customers appreciate the ability to move from design to actual working part in a timely fashion.
We have materials that are of high heat resistance. We have high impact materials. We have elastomer materials.
The speed is awesome. Time is the most valuable part of production.
It's the overall speed of printing, the level of details, the size of the part, the low maintenance of the machine, all these things combined.
And using the EnvisionTech bioplotter, we get a precision that we cannot achieve using other standard production methods.
The bioplotter really has helped achieve the goals in my lab. It really lowers the cost, increases the complexity, and versatility of what can be 3D printed.
The EnvisionTech printer and all the amazing things that it's capable of has been great for us because we can make the stop motion puppet much more complex.
By having a system like the Viridis RAM system, you essentially have your model in the digital domain. You can print that part on demand only when you need to.
It allows us to warehouse our customer's design on a thumb drive or a hard drive.
This technology allows you to keep your designs, your intellectual property, all of your work within your company. And you can reproduce it anytime you want.
The speed, detail, repeatability, castability gives you that confidence to be able to move your production forward.
EnvisionTech 3D printing is the standard way that we make dental restorations. Not only crowns, but with complete dentures and partial dentures as well.
It's definitely a greener technology. It's very much environmentally friendly when we compare it to the way we used to build products.
Today, EnvisionTech technology is the cutting edge, the greatest and the best for on-demand manufacturing, rapid prototyping process.
And the Envision One is something that you have to incorporate if you're going to lose out.
So the advancements that EnvisionTech have made are astounding. There's really no limit to what you can print. And I'm excited to see what EnvisionTech comes up with next.
Well, packaging is a hybrid packaging supplier, and our mission is to improve our customers' bottom line. 3111 is one of the offerings of Permanent Packaging. We provide design and development services free of charge because our customer success is in turn our success. We use 3D printing to create amazing visual models for our customers to understand what we're proposing to them. A 2D print never does judgment to a 3D shape.
We have a client that has a very specific design that they have narrowed it down to, and they want to be able to understand the actual look and feel, size, shape, everything about it.
We will go into a sketch phase. We sketch on tablets and create a wide range of concepts that fall within these parameters and then help our customer narrow down to a single solution.
We'll bring that into our CAD software and model into 3D, make sure that it's volumetrically correct, and then understanding the dimensional constraints.
From there, an engineer is approached. We work to make it manufacturable, and then we start building 3D parts to be able to review the concept and send to our client for their review and approval.
We print essentially 6 to 7 days a week.
The reason we picked the Extreme 3SP was because the Extreme 3SP has a large build envelope. We're able to build multiple balls at the same time with balls that have gone up to 12 or 13 inches in height.
It's nice to be able to meet multiple deadlines in one build.
Being an engineer, I really like the accuracy that we get off this printer. You're able to test things with high confidence and high precision, which lets you validate better.
We do a lot of things in glass. We do lots of high-end spirits these days, and a E-class clear model just looks so much more exciting than a 3D printed starch model.
The resolution of the final product is a lot higher.
Having something that is a similar look and feel to the end product does make it easier for the client to envision what their design is going to look like in the future.
To be able to crank out parts consistently day after day is great.
Our goal is to combine the things that are wonderful and creative and beautiful and appealing to a consumer with the realities of the manufacturing world and things that we can provide and make and sell to our customers and that they can sell to the consumer.
We're always looking for the latest tools that provide us what we need to develop extraordinary packaging.
enables the fulfillment of 3D printed parts. We do this by a combination of our digital platform capability and our physical fulfillment capability. 3D printing is obviously integral to what we do. The original vision was obviously to enable product creation, and 3D printing is a perfect medium for that.
Shapeways platform essentially is geared for anyone with or without a file. We have a network of design partners that we work with that's able to get a customer a file if they do not have one. Otherwise, the customer can go right onto our platform, upload it, and Shapeways on the back end is able to create that product through its network and have that product delivered right to the customer's door.
Today we ship 6,000 packages to about 130 countries around the world. For us, the Perfactor machines have been the workhorses of our EnvisionTech printers. We've had them since May 2016. They really service one large customer. It's a tabletop gaming figurine customer. On a daily basis, they're producing roughly 350 to 400 parts. We're running those machines 24 hours, 7 days a week.
We recently acquired 5 EnvisionOne machines. I think that's going to further enable us to advance at scale with our large industrial partners. Because of EnvisionTech's open system, it's allowing us the opportunity to work with other large industrial players within the material space, such as Henkel.
Henkel is a multinational chemical and consumer goods company. One of the things that we're known for is our Loctite brand. Over the last several years, we have developed several industrial-grade photopolymer resins targeting 3D printing technologies. EnvisionOne units have been critical in testing and validating our resins. It is able to run almost all of our current resins, including many of the high-performance options. This really speaks to the industrial capabilities of this equipment. We have been impressed with the quality of parts, the mechanical properties, and the accuracies which we are achieving.
EnvisionTech's EnvisionOne platform is now open to all of the capabilities that Henkel can provide from a material perspective.
This approach has provided customers with the best overall solution by combining an expertise in both hardware and resin options. Our high-impact resins have commonly been the choice for parts that require properties that can match injection molded or machine parts. We also feature several high-temp materials which can exceed 235 centigrade. We have a couple different elastomeric high-performance silicones which can be used for overmolding and flexible parts.
So now that the EnvisionOne technology is an open system, it now allows more material partners access to the CDLM technology.
It really is allowing us the capability to go after all the big players in the space that are underutilizing additive manufacturing, such as aerospace, architecture, consumer electronics, robotics, drones. And we could not be any more excited.
Composites is a proof of concept company that utilizes additive manufacturing. We manufacture 3D printed parts for our customers that literally go from the reaches of outer space all the way to 10,000 feet under the ocean and everywhere in between because of the versatility of EnvisionTech machines.
Some of the collaborative efforts between sales service companies, ACS, and 3D Composites have been for a number of Pacific Northwest spacecraft and aerospace manufacturers. We really knew right from the beginning that EnvisionTech products with the resolution and different materials could really help expand what 3D Composites is currently doing.
We start with two printers, the Vector as well as the Envision One. In 4 months, we've probably done over 3,000 parts on our machines already. They've been a combination of aerospace parts, medical parts. With the Envision One, we can hold tolerances down to 0.2 millimeters, and these are on very, very, very small parts.
The Envision One CDLM technology offers our customers the capability to be competitive because of the speed.
The build time is just phenomenal for 3D printing. I mean, there's nothing anywhere close to it.
The Envision One is a really exciting printer where we can change out materials in a relatively short amount of time and one day produce silicone parts for a medical application, and then the next day I can swap out the material in a matter of minutes and be running aerospace parts.
The rigid PU has a real nice toughness, so it works really good for composite parts for aerospace.
We were able to print 3 parts in 20 minutes of these small parts that would actually be going into the cockpit of 747s and produce the full run for a customer. Now there's about 40 of those parts flying around in 747s up in the sky right now, and will be for years to come.
The silicone type material that we print with is E5015. That works very, very well for gaskets and seals.
We were able to utilize E5015 material to produce gaskets for a satellite, and we'll be orbiting Earth in space someday. ABS Tough White has been a go-to material for us as well. The surface finish resembles a machined part surface, which our customers are just ecstatic about. And then the mechanical properties make it as if it were a machined part in certain applications.
We have 2 Vector 3 SPs, and what that brings to our business is that real high resolution accuracy for larger parts.
The high temperature capabilities of the Vision One HT with an extended Z axis gives us the capability to print in engineering plastics like E3955 FST material. The material passes the flame, smoke, and toxicity tests, which means that we can use them for a range of applications on automobiles, aircraft interiors, spacecraft. EnvisionTech has really allowed ACS and 3D Composites to expand on the markets and industries that we both go after for additive manufacturing.
And that's the reason why we are such a vertical company. We're extremely excited to grow with EnvisionTech. The technology is amazingly repeatable.
At EnvisionTech, not only do we invent and manufacture professional-grade 3D printers, we are also hard at work developing and improving materials for use in our state-of-the-art hardware. We also work with material industry leaders that meet the specific needs of clients from a wide array of industries. Our Envision One 3D printer supports an elastomeric photocurable resin. The high resilience and excellent tensile strength of this material allow you to make actual end-use parts, such as gaskets, tubing, and ergonomical items. Powered by the Envision One, this material allows you to make your elastic designs a reality. Powered by Henkel Loctite.
At Stacks 3D, our goal is to take your idea, come up with a solution, and deliver it to you. Quite often we are asked, so who do you serve with 3D printing? And our response is, it's a tool. So it is used for manufacturers, for the auto industry, even for inventors, entrepreneurs, there isn't an industry that isn't touching. Because we do serve so many industries, there's not one selection that's going to fit everyone. And that's the beauty of Envision Tech. The wide variety of materials allows us to customize specific to our clients' needs and wants. So customization is key, and Envision Tech takes care of all of that for us.
The 3SP technology in particular is really helping move the industry forward with its speed, precision, and different materials that you can leverage with it.
The Envision Tech Vector 3SP has really been a great service to a lot of our clients. The volume allows us to get some bigger prototypes that we haven't been able to see before in SLA. When it comes to service bureau work, sometimes we'll get one-offs, and we can use our Vita to take care of those one smaller projects.
We utilize the Vita for high-quality output components.
We truly believe that 3D printing is going to change cultures and inspire generations. And our job is to do everything we can to help people get there. We want to inspire people to use technology, and Envision Tech is one of the trusted companies that we use to help showcase just how easy this technology is and how impactful it can be in their daily lives and in their professional lives as well.
Envision Tech has been working for the last couple of years on advancing high-speed printing with the CDLM technology. What we've been doing with our R&D team that I'm so very proud of is developing a material tray that allows you to build flat parts. There's one big issue that comes with the usage of a oxygen permeable film. When you take the oxygen and apply it from below, you will create a dome effect. That means when you're trying to build a flat part, you're going to create some circles that represent the dome. The film has to be constantly stretched, which means you're constantly putting it under tension. So the life of the film is going to deteriorate quite fast. That's the difference between our domeless basement and the figure 4 and clip technology that's out there. We came up with a film that is a lot cheaper, but also, no matter what happens, under any circumstances, there will never be a dome effect. And when we build everything flat, they are accurate on the center and on the edges, and there will be no variation in the Z height, which makes the CDLM technology and the new domeless basement a great new experience that always delivers the best solutions that the customer needs.
My name is Miguel Gomez, and I am the 3SP Service and Applications Manager at Envision Tech, a global 3D printing company. Back in June of 2014, I got a phone call. It's like, hey, Miguel, I have your resume here, and I was looking through it, and you seem like a potential candidate for a position we have here. And I asked him, I said, what company is this again? And he says, Envision Tech. At the time, I knew nothing of 3D printing. So when he said Envision Tech, I jumped on my computer, Googled Envision Tech, and pulled up the website. And as I'm looking at this technology that I've never seen before, it looks amazing. I came in, he gave me the tour of the place, and this was when I had first seen a 3D printer in person. And he showed me parts coming out of the resin, and I had no idea that 3D printing was this relevant or out there at the time. He pulled me over, gave me the interview, and he gave me a mathematical electronics test, and he says I passed it with flying colors. He was really impressed, basically. And 2 weeks later, I'm working at Envision Tech. When I came on board, I was introduced to the Envision Tech family of printers that I was going to be working on, and I was assigned to the 3SP technology. And so the first few months in Envision Tech, I went from knowing absolutely nothing about 3D printing, and I picked up so quick that I was able to go out within a month and a half to my first install. It was great. I got to meet my very first customer that was kind of my own. I was very drawn into the technology, and I wanted to know more, and I wanted to provide more to the company. So I was here working late nights, weekends, working very closely with the CEO and with my management and with R&D, working on processes and softwares and materials. And after about a year, I became the lead prototype technician for the 3SP technology. It's been a great experience to be able to travel across the country and meet all these great people and companies. And I visited the dental space, the medical space, aerospace, the automotive industry, and help these people take their ideas from digital concepts to physical prototypes. In the past few years, I've been able to see EnvisionTech grow substantially, and I've been able to grow with the company itself, and just seeing the development of the 3SP technology and the DLP technology, the Vita, the CDLM, the Micro Plus. It's been very, very exciting. And I'm excited to see what the next 15 years has to hold for us, and I'm glad that I'm going to be a part of it.
3D printing has a dream. And sure, making cool stuff is part of it. But the dream is much bigger than that. So much bigger. 3D printing is about transforming manufacturing, making it faster, smarter, and more efficient. Eliminating waste and design limitations, and expensive tools that prevent inventors from taking risks. 3D printing makes sure everybody gets a chance to make their idea a reality. A lot of people talk about the dream, but at EnvisionTech, we've been delivering it for 15 years as the top 3D technology for mass customized hearing aids, paving the way for digital dentistry and bioprinting technology for advancements in medical research. We commercialized the first robotic 3D printing. At EnvisionTech, we've been pretty quiet about our leadership in 3D printing. That's because we've been pretty busy delivering the 3D printed dream.
Αυτά από εμάς. Για περισσότερες λεπτομέρειες ή πληροφορίες μπορείτε να επικοινωνήσετε μαζί μας στις διευθύνσεις και στα τηλέφωνα που είναι στο προφίλ μας στην έκθεση. Ελπίζω να σας άρεσε. Καλή συνέχεια. Γεια σας.